This is section 9.3, Special Products. So far we've been using the FOIL method to multiply two binomials, and that will always work. You can always use FOIL. It's just that sometimes it takes too long. There are actually certain patterns in the multiplication of two binomials that will help you solve the problems if you recognize the pattern. So if you see that it fits one of these patterns that I'm going to show you today, you can easily find the answer. And the first one is the square of a binomial. So we're going to look at a plus b squared, and that equals a squared plus 2 times a times b plus b squared. So what you do here, when you have two terms squared, you square the first one, you square the last one, and then your middle term is always 2 times the first times the last. That's where we get that 2ab. So the pattern we're looking for is a plus b squared, and the answer will always be a squared plus 2ab plus b squared. So when you look at x plus 5 squared, that follows the pattern a plus b squared. So you know the answer must be the first term squared, that's x squared, the last term squared, that's 5 squared, or 25, and the middle term must be 2 times x times 5, that's 10x. So it's x squared plus 10x plus 25. In the next example, 3x plus 4 squared follows the same pattern. That's a plus b squared, right? So you're going to square the first term. Now remember, when you square 3x, you have to square the 3 and the x, so that becomes 9x squared. You square the 4, that's 16, that's your last term. And the middle term will be 2 times 3x times 4, so that's 24x. Now the takeoff on this is to have subtraction in the middle. So instead of a plus b squared, we're going to have a minus b squared. Whenever you have a minus b squared, you square the first term, you square the last term, and then it's minus 2 times a times b. Now because this pattern has the subtraction built into it, you don't consider that subtraction when you're squaring, although squaring a negative number will always give you a positive number. Just ignore the subtraction sign in the beginning when you're squaring b. So we're going to square a, then we square b, and because there's a minus in between the two, we do minus 2 times a times b. Okay? So we're going to separate that minus sign from the b, if that makes sense. So when you look at this example of x minus 1 squared, we're going to square x, that's x squared. We're going to square 1, that's 1. And then we're going to multiply negative 2 times x times 1, so that's minus 2x. In the next example, 2x minus 3, again, that follows the pattern of a minus b squared. You square 2x to get 4x squared. You square 3 to get 9. And then you multiply negative 2 times 2x times 3. So that's negative 12x. In the last example, you have 4x minus y squared. So we're going to square 4x to get 16x squared, and square y to get y squared, and then take 2 times the first term. So that's 2 times 4x, that's 8x, times y. So it's minus 8xy. The next pattern we're going to look at is the sum and difference pattern. If you have something that looks like this, a plus b times the quantity a minus b, in other words, you have the same thing being added in the first parentheses that you have subtracted in the second, the answer is always a squared minus b squared. Always, always. You can multiply that out using FOIL, and you'll see that there is no middle term there because you have a negative ab and a positive ab, so they're going to disappear. So you get a squared minus b squared. So if you recognize that when you see it, it's really easy to calculate the answer. If you look at x plus 3 times x minus 3, that follows the pattern, so you know the answer is the square of the first term, that's x squared, minus the square of the second, which is 9. So it's x squared minus 9. Same with the next one. T plus 5 times t minus 5 must be t squared minus 5 squared, which is 25. You can do this with more than one variable too. In the last example, you have 3x plus y times 3x minus y. You square 3x, so that's 9x squared, and you square y, so it's y squared. And you subtract the two, so it's 9x squared minus y squared. This system really comes in handy when you're doing mental math. You know, for example, when you're looking at 26 times 34, you don't have a calculator. Think of 26 as 4 less than 30, and 34 as 4 more than 30. Okay? So you could use the sum and difference pattern here. You could take 30 minus 4 times 30 plus 4, and right away you know the answer is going to be 900 minus 16, that's 884. Okay? That's just one of those math tricks that people use all the time that you might want to take a look at. It's really simple to multiply when you know these patterns. And the last thing we're going to look at in this section is Punnett squares and probability. I don't know if you've done these in science yet with genes and the probability of having an offspring with certain characteristics, but they're looking at a problem here where you're mating collies with genes for black patches. They call that a capital B gene, or red patches, a small r gene. And there are actually 4 possibilities for the offspring. They can have 2 genes that are capital B's. They could have a capital B and a small r. They could have a small r and a capital B, or they could have 2 small r's. Now, any offspring with a capital B is going to have a black patch on it, but only the offspring that has the 2 small r genes is going to have red patches. So of these 4, you can see 3 of them are going to have black patches. That means there's a 75% chance of having black patches and only a 25% of having red. But you can also use a polynomial to model this. If you think of the parents as each having a black and a red gene, and there's an equal chance of inheriting either one, then the possible genes of the offspring are actually 0.5b plus 0.5r squared, because you have a 50% chance of getting each gene, and you're squaring it because you have the parents both contributing those genes. Okay? So when you multiply that out, we see that it's something squared, and you know how to do that now from our pattern. You square the first term, you square the last term, and then you multiply 2 times the first times the last. You're going to see that you get 0.25b squared plus 0.5br plus 0.25r squared. Now, what does this mean? Well, it actually means the coefficients here are actually the probabilities of having that gene mixture in an offspring. Okay? So when you look at it, you can see that there's a 25% chance of having B squared, that is 2 capital B genes, a 50% chance of having capital BR, that's still going to be black patches, right? And a 25% chance of R squared, that would be red patches, which we sort of knew already, but this polynomial confirms it. You can also draw this out into squares. That's why it's called a Punnett square. So you might want to take a look at that in your book so that you're familiar with it.